We're going to talk about solving radicals and graphing. So when we're solving radical equations, even roots cannot equal a negative number. So basically, we're looking for real solutions. It is very important you check your answers. No, x can be a negative number, so x can be a negative. But if you start getting i's, we're not going to go with that. We're going to the radical alone, undo the radical, solve for x. And always check your answer in the original problem. So for number 1, we're going to solve this. The first thing is to get the radical alone. So this minus 2 is on the same side as the radical, so we're going to add 2 to both sides first. So we'll get the square root of 9 minus 5x equals 8. Now we undo the square root by squaring both sides. So 9 minus 5x equals 64. And then we're going to solve normally. So subtract this 9, negative 5x equals 55. And divide x equals negative 11. We take the negative 11, we would plug it back in for x to make sure it works. It does. So we have one solution here. For problem 2, we've got 3y plus 1 to the 1/3 power plus 5 equals 0. Remember that a 1/3 power is like a cube root. So the first thing we're going to do is we're going to move this plus 5 because we want to isolate the radical. You could rewrite it as the cube root if you want to, but you don't have to. So I know I'm going to raise both sides to the 3rd power to undo it. So we're going to get 3y plus 1 equals negative 125. Subtract the 1, 3y equals negative 126, and divide by 3. So y equals negative 42. We take the negative 42, we would plug in where y is up here and make sure that this would all come out to be 0. And it does, so life is beautiful. For 3, we want to get that 6th root by itself first, so we're going to subtract 4. So we're going to have the 6th root of 4x plus 1 equals negative 3. And then we're going to raise both sides to the 6th power. So we're going to get 4x plus 1 equals 729. We subtract 1. 4x equals 728. Divide by 4. X equals 182. And then we're going to take the 182 and we're going to plug in for x into our original equation and see if this left side does indeed come out to be 1. It does not. When you plug 182 in, you're going to get 7 equals 1, which is not a true statement. Therefore, this is not a solution. And sometimes when you have no solution, they're going to do the empty set brackets. For 4, we can't really isolate the square root because it's on both sides, so we're just going to square both sides. If I had addition or subtraction outside the square roots, I would not be able to do this. So we're going to get x minus 5 equals 4 times x plus 1. Remember, square roots and squares cancel each other out. X minus 5 equals 4x plus 4. And then we're going to get x's on one side, numbers on the other. So we get negative 3x equals 9. And x is going to equal negative 3. When you plug that in, you're going to get the square root of negative 8. So it would be an imaginary solution, which we're not doing, so we have no solution. For the fourth root of x plus 5 minus 2 equals 0, we're going to isolate the radical, so we're going to add 2 to both sides. So we have the fourth root of x plus 5 equals 2. To undo a fourth root, we're going to raise both sides to the fourth power. So we'll have x plus 5 equals 16. Subtract 5, so x equals 11. In this case, when we plug it in, it does work. So we're happy. We have a solution. I want you to try the next two and check your answers on Schoology. So pause the video, try the next two, check your answers on Schoology. The next section is going to be radical graphs. Obviously, rational is a typo. That's what we're doing next unit. It must have been on my brain. So radical graphs have a restricted domain. The domains that we've been looking at recently have been all real numbers. Now we're going to get some different ones. To find the domain of a radical function, so whatever is under the radical greater than or equal to 0, and then solve. So for example, if you have f of x equals square root of x plus 7 minus 12, you just take the step underneath the radical, so x plus 7 greater than or equal to 0, and then get x by itself, so x is greater than or equal to negative 7. Remember to flip the symbol when you multiply or divide both sides by a negative number. So the first part, we're just going to find the domain, and then we'll actually graph it and do the characteristics. So for number 1, to find my domain, I'm going to take the step underneath the radical, so x minus 1, and set greater than or equal to 0 to get x by itself, so I'm going to add 1. So x is greater than or equal to 1. So my domain is x such as x is greater than or equal to 1. For number 2, I've got 3 plus the square root of x plus 5. I don't care about it if it's not underneath the radical. So I'm just going to say x plus 5 has to be greater than or equal to 0. I'm going to subtract that 5. So x is greater than or equal to negative 5. X such as x is greater than or equal to negative 5. We're going to state the transformations, then graph the equation, and find the graph characteristics. So when I look at this for my transformations, I'm going to go right 1 from the minus 1 underneath. I have got a vertical stretch by 2, and that's the 2 on the outside in the front. The negative on the outside tells me I'm reflecting across the x-axis. We're flipping upside down. And the plus 2 on the end of it means I'm going up 2. So for my domain, I'm going to set x minus 1 greater than or equal to 0. So x is going to be greater than or equal to 1. And then I can graph it in Desmos, or I can plug in some values to figure out some of these answers. If I take 1 minus 1 is 0, square root of 0 is 0, negative 2 times 0 is 0, plus 2 is 2. So I'll point out 1, 2. I want to be able to square root, so let's do 5. So if x is 5, 5 minus 1 is 4. Square root of 4 is 2. And then negative 2 times 2 is negative 4. So we're going to get negative 2. So my range is less than or equal to 2. My x-intercept is at 2, 0. My y-intercept is none. When I look at my graph, I have no increasing. I'm decreasing from 1 to infinity, and my absolute maximum is 2 at x equals 1. My absolute minimum is none. And my end behavior, as x approaches 1, f of x approaches 2. The left side is x approaches infinity, f of x approaches negative infinity for the right side. I want you to try the next few, so put this on pause. If you aren't looking at the notes on Schoology, and try these on your own sheet of paper or the printout copy of the notes. And then check your answers on Schoology. Do your graded classwork on Schoology, any optional practice that you want to, and your mini concept check.